Okay, so today we're looking at section 4.6, which is formalizing relations and functions. So hopefully by the end of this video you can say that I can determine whether a relation is a function. I can use a vertical line test to determine whether a graph represents a function, and I can find the domain and range of a function. So first thing, can we determine from a table if something is a function? So take a look at this table that I give you here, determine whether it's a function or not. And hopefully you can see that down here we have a 2 paired with two different things. First it's with an 8 and then it's with a -6. So this one would cause it to be not a function. The thing we want to look at today is what does that show up as on a graph. So if I were to graph these points, I'd have a -2, 6. I'd have a 0, 5. I'd have a 2, 8. And I'd have a 2, -6. Okay, if I look at this next one and determine from the table, first of all, if it's a function, we can see that the -3 is paired with two different things. So this one is not a function. And again, this input of -3 is paired with two different things. So we'd have to say it's not a function. So if I graph this, I'd have a -3, 5. I got a 4, 5. I've got a -3, 8. And I've got a 1, -6. Okay, if I flip to the next one, okay, go ahead and take a look, see if you think this one is a function. And hopefully we can see that since this 2 is paired with a 5 and then with this 8, this again is not a function. So if I look at this one on a graph, I've got a -3, 6. I've got a 2, 5. I've got a 2, 8. And I got a 1, -6. Okay. And this last one we're going to look at, if I've got these ordered pairs, we can see that there are 2 3s. So this one, again, not a function. And what does this look like on a graph again? It would be a 3, 6, a 2, 5, a 3, 8, and a 1, -6. Okay, and if I take a look at my graph, I can see that these two -3, or these two 3s, here's the points that correspond with them. If I look at the 2s, here are the points that correspond with them. The -3s, here are the points that correspond with them. And the -2, or excuse me, the +2s, here are the points that correspond with them. So hopefully we can see from these graphs that when I have things that are not functions, I have 2 points that are stacked on top of one each other, or a vertical line would touch both of them at the same time. So what are we going to use? We're going to use something called the vertical line test to determine whether things are a function or not. So if I were to take a look at this, and I take my vertical line, here's my tester, I take my tester and I pass it through, I can see that I'm never going to hit more than one of these points at a time. So this right here is an example of a function. Okay, if I go to my next one and I take my vertical line and I pass this one through, I can see that right here I'm going to get a vertical line that hits more than 1 point. So I'd say that this one here is not a function. Okay, so that one is not a function because it hits more than 1 point. Okay, if I take a look at this one and I grab my lucky thing and I slide her on through, it's never going to hit more than 1 point. So this one right here, we would say is a function. Okay, because it did not hit more than 1 point when I slid the line through. Okay, if I take a look at this one, I'll let you determine. And we should be able to see that this one is not going to be a function, because if I took that vertical line and I passed it on through here, we should be able to see that this is going to hit more than 1 point. So this is not a function. Okay, if I go to the next slide, okay, once again, if I took my pointer and I slid this through here, I can see right here that I'm going to hit more than 1 point. So this one here would again be not a function. Okay, next thing. We want to be able to identify a domain and range of a relation. We want to use mapping diagrams to determine whether a relation is a function. Okay, so first of all, a domain. The domain is simply a listing of all the inputs. The range is simply a listing of all the outputs. Okay, so if I ask the domain here, I'd have a 2, an 8, a 9, a 4. That would be my domain. My range would be a 4, an 11, a 1, a 2. Now the mapping simply looks like this. A 2 maps to a 4. An 8 maps to an 11. A 9 goes with a 1. A 4 maps to a 2. This one is a function. There is not any input that maps to more than one output. Okay, if I look at this next one, number 2, domain and range. Domain would be a 5, a 3, a 1, a 0. The range would be a 2.2, a 2.6, and a 2.5. A mapping would look like this. A 5 maps to a 2.2. A 3 maps to a 2.6. A 1 maps as well to a 2.6. And a 0 maps to 2.5. Now, this one we would say is a function. Some of you may be looking at the, oh, let me rewrite that. Remember this 6 here, 2.6, this right here is a y value, so we can have a y value with two different inputs, but not vice versa. Okay, so if I did it here, domain on this one would be a -4, a 1, and a -1. The range would be a -6, a -2, a 4, and a 2. So if I did my mapping, it would look like this. A -4 maps to a -6. A 1 maps to a -2. A -4 also maps to a 4. And a -1 maps to a +2. So from this, I can see that this -4 maps to two different things. So we'd say that this one is not a function. Okay, then pause the video, see if you can do this last one by yourself. Okay, and then what you should have came up with is this. The domain is a 6, a 5, a 2. The range is a 5, a 6, and a 2. So my mapping would look like a 6 maps to a 5 maps to a 6, a 2 maps to a 2, but also maps to a 6. So again, we can see here that we got the rule breaker, and this one we would have to say is not a function. Okay, so hopefully, we're at the end of the video. Hopefully you can say these three things. I can determine whether a relation is a function. I can use the vertical line test to determine whether a graph represents a function. And I can find the domain and range of a function. That's all I have for you. So that is a wrap.